Hello and welcome to Diode Circuits and the Model Editor tutorial. In this part of the tutorial, we will use the breakout diode model. Let's enter a simple circuit. I'll just use the breakout library. We'll just make sure it is selected. And we will use the break model of the diode. We will also use the V-sign source because we're going to do a transient analysis. And the 1K resistor. Now let's set our ground and wire the circuit. Right now we set the offset voltage to 0, the amplitude of 5 volts, and the frequency of 100 Hertz. Now let's click on our diode and do right click and go to Edit Pspice Model. Okay, right here you can see a window of the model editor, and you may change the values of any parameters in the window on the right, or you may add additional Pspice parameters that are part of the Pspice diode model. A list of these parameters can be found in the Pspice manual. For the first time, we're not going to change anything, and we're just going to go save and close this window. Let's set up our simulation profile. Our runtime will be 0.05 seconds, and the maximum step size will be 10 microseconds. Okay, let's not forget to put our probes and run the simulation. As you can see, we have the same result as we had in the previous tutorial. Now let's go and change parameters in a model, Pspice model. We'll reopen the model editor and add the parameter n equals to 2 to the list of the parameters. Recall that the n appears in the denominator of the exponential in the diode model. Let's save the new model and rerun our simulation. Now note that the output voltage dropped due to the change of our n, the value of n. In this part of our tutorial, we will determine IV characteristics of the diode. Let's go ahead and build a circuit, and we will use two models of our diode. We'll use two breakout models. We're going to use VSRC source because we're going to do a DC sweep. Alright, now let's go ahead and change our parameters. Right click and edit Pspice model, and right here we'll change the parameter of n equals to 2. N equals to 1, and we'll call breakout model as n equals to 1 and save changes. Notice that in the left window the model name changed to Diodebreakout. Let's change the second model, and here we'll change n to be equal to 2, and our debreak is going to be 2. Again, notice that our name or model name changed to debreak equals to 2. Alright, let's go ahead and create a new simulation profile. We'll call it DS sweep. Okay, and we'll choose a DC sweep. And our voltage source was V1. Our start value will be -2. Our end value will be 2.5 volts. And our increment is going to be 0.01. Let's apply and let's run our simulation, but before we don't forget to put probes. Alright, let's now go ahead and adjust our axis. So, and after modifying our axis, we're gonna see that different n values have a different IV characteristics of the diode. In this part of our tutorial, we will take a look at a simulation of a Zener diode. A breakout of Zener diode can be found in the same breakout library, and it's called Diodebreakout. Let's go ahead and put it in. Alright, let's edit Pspice model. And in the right window, using our specification sheet for Zener diode, we can determine the typical Zener breakdown voltage BV, and in our case it's going to be 10 volts, and IBV, and in our case it's going to be 20 milliamps. That's how you enter this in a Zener diode Pspice model. Now we'll just close the window, and we're not going to do any simulation, so we're not going to save any changes.